Mr. KCDH Arora from CDAC. So as I mentioned in the last meeting, we have a large consortium across faculty, IIT Bombay, IIT Delhi, IIT and so on, and CDAC, Noida. Mr. KCDH is there.
Yeah.
You might know him.
Good
So,
morning.
and we have Mr. Tushar as well.
Yeah,
And
good morning.
we were there also last time. We also have Dr. Venkatapati and Siddharth, who are members from IIT Bombay. I guess you have Bhupender with you. He's probably just reaching your door right
Yeah,
now.
right now he has already reached there. Sir, I'll request Rao sir kindly to allow him to join there physically, sir.
Yes,
Yeah,
Dr.
no
Rao,
problem. I've informed at the reception. If he's reaching
Yes, sir.
here, he can come to me.
Sir. Right now he's
And
reaching, sir.
yeah, so okay, so from
so
our side, actually, I've asked my other team members to join. But meanwhile, we have Neil Ratan sir with us, who is a volunteer at NHA. He's working closely with many of the digital projects, digital health projects. So Neil sir is here, and as others find time, they will join also. So maybe for time factor to save time, we can continue actually.
sure. So we'll summarize all the work that we've been doing so far with demos on OCR for medical domain, and also we'll provide you some the demonstrations. That will also give you an idea of what is there to come. So I'm in a busy area. Venkat will, Dr. Venkat will speak. Venkat, go ahead. Venkat is a postdoc with us at IIT Bombay.
Hello, good morning everybody.
I'll
I
connect
hope my
here
screen is
so that
visible.
there is no.
Is my screen visible, Siddharth?
Yes, your
Yes,
screen
yes,
is
go ahead.
visible.
Yes. So today's discussion will be around of why we need for OCR and some of the features that we are going to discuss, because we are not just going to stop with OCR, go beyond that. And the second point we'll discuss is what are the features and what is the accessibility for those features that we are going to provide, and how are we doing that will be the third point of annotations and training, etc. So as we know, uh, the need for OCR is there are a lot of visits to the hospitals, thousands of visits per hospital based on a 2019 survey, and there is a lot of medical records that is there. An average medical hospital can produce up to 1 lakh medical documents. That also includes the lab tests, diagnostics, bills, discharge summary, etc. And with the ABDM in the game, we know that all this is going to be in a semi-digitized format, that is scanned, not fully digitized, or some of it are partially scanned. So there is going to be a lot of mismatch and everything is going to come. And
Just the use case we are talking about here is not just this is TMJ-why it has a lot of existing records to be digitized. So ABDM is a little futuristic. Right now we are talking about more
yes,
immediate requirements. I think we should just move to
yes,
the next
immediate.
one.
Yes. So what are the plans that we have? OCR on medical records. So we are constantly working on the SOTA model for OCR framework. In fact, we are part of the team that works with MEITI on OCR and its applications for Indian languages. We have about 100, in fact, models for all the languages of Indian languages plus English. So that we and our focus is not just OCR but also layout preservation. That is, if you have a document, we know that different hospitals have different format. We wanted to preserve the layout as well as get the data from there. That is number one. And data programming, when we say data programming, we can think of all the years of research on OCR need not be gone wasted. We can convert them into simpler programs and somehow plug them together and make it work for us. So with all the invaluable information available with medical record, we can tag what are the most important information we needed and how to take it automatically. That's what data programming will do. And finally, high fidelity data extraction, which is crux of the problem with medical document, because we'll have different layouts. For example, COVID reports will have different layouts, or some other check sugar report will have a different layout. So we wanted to extract precise information, making medical and security checks easier. For example, if you in an airport, if they wanted to scan a COVID certificate and you want to find out the patient's name, Aadhaar ID, and whether it is positive or negative, you just need those specific information. That's what high fidelity data extraction means. So how are we going to give the features and accessibility for that? Our project focuses on the application and accessibility of the medical records, and it can be integrated with any existing hospital information system. So this is like a plug and play model, and it can be used with any HIMS, past and present. And we also offer high quality OCR and high fidelity data extraction from documents, and we are constantly improving on that, and that can also be easily plugged and played. So the features that we'll be looking at is four. One is data programming. Like I said, data programming can be thought of, Sir was also saying that a lot of NHA members is also working on OCR. So instead of finding out which is the best, what we can do is we can put all the best one into different arrays and make the system choose based on which is important. So the data programming is something human in the loop concept, where the humans can write some functions, noisy functions, and the system will learn a model that can generate based on those noisy functions and labels on top of that. That is data programming. We have an inbuilt platform. So diagonally, you can see Spear. Spear is for data programming, semi-supervised data programming. And the other team which is working, Spear is completely in-house. It is developed in IIT Bombay, made in India. And the other team that is working on similar tool, ours is better on that, which is like the Stanford. And they have, for example, open sourced, and we have gone a little ahead where we can also integrate different AI models on top of that. So based on these two, data programming and Spear, what we can do is write what is something called as labeling functions. Labeling functions can tag important data to a specific type. For example, if you have a COVID, I'm bringing back the COVID so that it is coherent. In COVID report, you know where the Aadhaar is for some of the labs, right? So we can mark the layout manually with our tool, or we can mention that I wanted name, I wanted Aadhaar number. Aadhaar number can be written in many different ways or different languages, but you want that key. So these things can be mentioned in the labeling functions. And after writing this a lot of noisy labeling functions, what we can do is finally is a field extraction. Basically, for a document, we would like to extract necessary fields that is among the nest of words. So OCR is not enough for medical data. We go beyond OCR and get the field extraction. So here is an example. We have an invoice, for example. We know that OCR can find out this is invoice, this is number, and some number is there. But what we wanted is invoice number as one, and its corresponding, that's the key, and the value will be the actual invoice number. Invoice date is the key, and this is also called as name entity recognition. I can see NHA is working on that. But the breakthrough here is we can target different layouts. For example, the position of the field of interest can differ in different documents. In here itself, you have different ways of mentioning the date, and the format is different. And they are typically have a position, relative positions. It can be on the right side, it can be below. We know that humans know this intuitively. And what we can do is we can write labeling function saying that if you find a word, keyword called invoice, and if you find some values on the right side, then that will be the key value pair. So this is a kind of writing a heuristic rules for a model, and the model will learn based on that. So it need not be strictly on the right side. Sometimes it can be a little below, or on the below, or it can be in table, which in the case of medical reports, lab reports, it will be. So all these labeling functions can be generated, and the field can be extracted. So this is the technical way of doing that. You write a lot of these what is called as labeling functions, which any
My request, Dr. Rao, is if there are questions the team has, they can please feel free to interrupt at any point of time, because this is meant to be interactive. So, and we'll do demos. Please feel free to.
Yeah, sure. Even we have Mr. Jaydev also with us. I mean, as and when there is anything, we can ask. Yeah.
Sure.
So for writing these labeling functions, any of basic programmer will do. They just have to understand what is how the lab reports, and they have to convert that into programs. And then we have our deep learning generative models, which will take these labeling functions, heuristic labeling functions, and vote them. Not simplistic voting, but we use mathematically sound deep learning methods to come up with to choose the better values, and then we build a discriminative model on top of that to do the name entity extraction. So data programming can solve the problem using weak supervision. This is called as weak or distant supervision, because any model will work for the OCR for medical records, but the challenge is for different types of layout we have to generate these labels, and it's very costly to hire somebody to sit and make him work on that. So what we do is a couple of programmers can write these weak functions, weak supervised labeling functions, and that can cover, let's say, 1 lakh document, 2 lakh document, and that way we can cover a lot of these data in smaller amount of effort, right? And then we can use this generated data for training in model. So this is the philosophy of data programming, and it has been successfully deployed in a lot of these Apple, Google, and many of these places, and we have applied that for our OCR for medical domain. So
if I may ask something here. See, in medical records, the challenges we have to handle a variety of reports, not just a lab report. There are discharge summaries, there are operative notes, there are investigation reports, CT scans, and MRIs, which follow, each of the report follows a different pattern. And even then, they are not standardized. Some in a big chain of hospitals, you may find some standardized reports, whereas in a smaller establishments, you will find from a handwritten to any of the non-standard format of reporting. So how does your this programming handle that to cater to this variety of reports?
Yes, sir. So, for example, let's say we have 1,000 reports that are not properly formatted, but similar. They are grouped. They can be grouped into similar, right? Roughly, they can be known that this position it will be there or this box will be there. What we can do is we can take 1 or 2 of those reports and write labeling functions for that. Just 1 or 2, like very minimal number, maximum 10, up to 50 we have tried. And what happens is using that functions, it can cover most of it. And heuristically, we have found out that if you have about 4 to 5 labeling functions, a proper labeling functions, it can cover up to 80 to 90% of data, any kind of data. So that is why we are going for data programming. The concept here is it's non-standardized, and you are having access to 1 or 2 labelers, let's say labeling functions, who can write functions, and then on top of that you can cover these documents. So the idea is you have a small label set. You can see the diagram here. You have a very small label set, and you have a lot of labeling functions, and then you can have a almost unlimited, countable infinity number of unlabeled data set, and then you apply those labeling functions. You can basically generate those data, and then you can apply some kind of learning algorithm on top of that, which can be then used for training any kind of models. So here,
can I come in, please?
Yes, sir.
Just I think the probably the question Dr. Rao was also trying to get to is for how many types of reports or how many of these templates have already been made?
Okay, so we are working currently with Narayana Hridayalaya. There we have successfully deployed with their part of they have a records for about 20 years old scanned copies. There we have successfully tried up to 80 to 90% of accuracy we are getting. And then what we do is we are also trying to implement this into a large open source hospital management information system called Bamini, where we are giving a framework where the user can choose. I'll also show a demo where the user can just select those regions, and then when they click yes or no, automatically this labeling functions will be generated. So we have executed this for 3. We have also a couple of hospitals on top of that. And Bamini has a large user base. It's one of the largest HIMS. We are integrating there. There we'll expect a lot of these use cases. So currently we have about 10 to 15 types of formats that is there. And what we are proposing is not about the formats. Like I said, it can be any type of format. What we need is just a couple of data that can be used for clustering this. I'll also show one example how this clustering is done. Yeah, here, for example, we are using some kind of different types of clustering algorithms successfully. One of which is this DB scan. You can see that here we roughly need to know that the patient's name will come on the top. You don't need to know even the position. And some of the lab reports will come in the middle, and not necessary things. For example, signature of the document will come at the bottom, right? Additional notes, doctor signature. If you know this, what you do is you just give some data and try on some of these tests. That's what we did. We did not do a lot of labeling on this. We just gave some parameters, and it was working very well for the rest of the documents. So what we need is we find out a group of cluster of documents. It can be a summary, for example, discharge summary. We are showing example on lab reports, but even in discharge summary, OCR is already taken. But let's say we wanted to know specific fields. When was the patient discharged? Or what was the cost that was incurred? What was the medicine that he needs to take for, and how many months? So if we know the names, fields, and if we know, for example, which area it will come, or even knowing the field is enough actually for labeling functions. We give that as functions, then it will try to learn from that. So that will cover major of things. Does it answer the question?
Yeah, I think just a little bit of a follow on from there. Say, for instance, as you said, for Narayan Hridayalaya, we've done whatever. So, what is how many documents have we successfully, and how many types of documents, and how many what broad volume have we managed to extract meaningfully? So that will probably give a sense. You said 15, 20 types of documents we've done.
So we have done on lab reports, CT scan, Siddharth, and what else do we have?
Yeah, right now we have tried on discharge summary, we have tried on lab reports, and we have tried on CT scan.
Okay, yeah, these are the
of
3 reports we have
formats.
Done. Yeah, of different formats.
But so they're not.
So if I may just, sorry, sir, please go ahead.
No, okay, I'll complete them. So it's right now, I think so if I may understand for Narayan Hridayalaya also, so for 2 or 3, these 3 format types, we tested with them for a volume, but have they kind of started deploying it on live use yet, or it is kind of in the dev mode and working with them?
Yes, sir. It is still in dev mode because we are working on it's a research grant. So what we have to also do is show the results. So what we do, manually check with an annotators and make sure that the ground truth is generated for testing purposes. That's why it has been slow, but the project is for 2 years. At the end of the second year, we are already in talks with the Narayan Hridayalaya technology team, and we are trying to incorporate those things. So that will be down the lane in, let's say, 4 to 5 months. What we need now is there's a lot of these data. That is where we are lacking. For example, even for Narayana Hridayalaya, they have to go through ethics committee, and they don't have a team. We have to do it. For example, if we can deploy it with NHA, and NHA can take it forward and check it with a lot of their data and see how well it is performing, that will also give us a good picture on where it is going.
So we'll come back to that point in a bit, but Dr. Rao, you please go ahead.
Yeah. I mean, my point was that as you mentioned that you have done only with Narayan Hridayalaya, and that too only 2 or 3 templates. A single facility will have a uniform template, right? But if you see the magnitude of, I mean, the kind of hospitals different, I mean, spread across all over India, following various formats. non-standard formats. So then how does your model work on them? So that's my question actually.
Yes, sir. So
Let me offer clarification. Venkat, let me offer this clarification. The approach is such that it generalizes very easily. Uh, so maybe Venkat did not. Maybe Venkat should go over the process again. Given any new format, you only need a couple of instances, 2 or 3 instances actually. That's all you need. It's not that you need a lot of annotated data. The model, the existing model gets completely fine-tuned based on a handful of instances for that format. So that's why we are very extremely confident. This is actually deployment ready as far as the machine learning model is concerned. We're extremely confident that you give 1 or 2 instances, even one in fact I would say, we are saying 2 or 3 for robustness. Even one may be sufficient. One instance from that structure could be sufficient. Now you could have a cluster, like let's say one type of format. From that you just need 1 or 2 representative instances. So we are very confident this generalizes very well. I don't know if that helped answer the question. There's actually based on this data programming, right? It is right through examples or exemplars, which could be a handful. There's in fact a complete startup at Stanford called Snorkel. What we offer is in fact a much more robust version of what Stanford has, but that's actually in production. They deploy it in industry because industry has this problem. They can't always, yeah, this is the web page is showing, the Venkat is showing. This is a Stanford startup, open source software called Snorkel. We have average, but we have, I would say, in-house and much more robust version of it, which is exactly what Venkat is showing. So this is in one sense deployment ready. Dr. Rao, did I make?
Yeah, I have no further questions. I mean, if Jaydev wants to ask something, he may.
Okay.
Thanks, Dr. Rao. So this looks interesting from the perspective of well, personally, I have not seen too many applications of generating and generative and then discriminative networks. Is this what you'd call a GAN? That part of the architecture?
no. Okay. So what we are generating here is not from out of like it's not without any output. You have what is called as
these are
gaming
just
function.
literally generative and then discriminative models. There is no
Yes.
adversarial interaction between.
Yes.
I see.
Yes.
It's not
Understood.
adversarial. Yes, it is. It's called data
Go on.
programming. Yeah. So the generative model is associated with the programs, the rules, the bottom-up agglomerative clustering based segments. So that's the bounding boxes you create. Generative model is only about associating probabilities with those, and the discriminative model takes care of final extraction. So, so the GANs can be very unwieldy, right? And they're very unstable. And sometimes you require a lot of training. This is very simple approach.
Understood. Understood. In fact, I mean, again, speaking for myself, I'm somewhat conservative when it comes to, widespread applications of deep learning because, what we are using also right now is something that does OCR followed by named entity recognition. And then we have a bunch of heuristics on the output, which is similar to what you would call data programming. But the problem is that since the very first stage is is this transformer, which is doing some computer vision and some NLP for us, we still have to spend a bulk of time training and annotating, which by itself is fair and we can't get around that. But the problem that I foresee there is that if it turns out to not produce good results, then that's like weeks of time and effort. Correct. So that's why I'm somewhat conservative about deep learning methods. Wherever if they're required, they're required. You can't help that. But if they can be avoided, that's better. What I find promising about and this is for Dr. Rao. What I find promising about this is that apart from the OCR and the NLP that they are doing, they also have a bunch of different heuristics, which ought to sort of which seems like it sort of balances out the error across multiple stages. There isn't one bottleneck which is going to contribute to all the error.
Exactly. So I wanted to share one
No,
experience.
actually,
technical
no
experience
question
on this.
for Ganesh and others is like, is that a fair assessment in the first place? What I said.
I was about to react to what you're saying. Yes. The only caveat, only qualifier there is these heuristics are not directly used. The heuristics are used through this generative model. So it's a human intuition, human heuristics. They are kind of being validated by the model through the generative like counterpart. So the generative model is associating probabilities or weights. What will be the simplest aggregation? It's majority voting, right? If I have 10 different rules, I can do majority voting. We are saying we can do a lot better than majority voting because some of these heuristics may be very noisy, right? So you said heuristics. Some heuristics could be so noisy they're all over the place. So our model is able to figure out that this is actually a noisy heuristic because it's just fires and misfires indiscriminately. These others, so there's more specifically, the generative model is a consensus model. It looks at consensus between these heuristics based on their patterns of firing. It's a technically we call it a graphical model. So that is what the generative model is. Um, the While certainly deep learning is beneficial, this complements deep learning. So it's not that you need a deep learned model to be fine tuned on every new setting. This kind of can override the deep learning model. So it's sitting in parallel, you can override, but yet at the same time, there's a principled generative model through which the probabilities are being learned. I agree
Sure.
with what you're saying. I'm just trying to further qualify what you said.
Understood.
I
One last
also wanted
question
to
is,
add on top
do
of
you
that,
think?
sir. Yeah,
Please go on.
go ahead. So just I want to share this experience because you talked about having a transformer. We also have a layout LM transformer on top of this. Like you said, the layout LM is we have a lot of these name entity recognition transformers. The reason being LM model, and it is doing good. Like you said, the problem is you have to train it with a lot of data, and that is where our this data programming, the Sphere framework will help you. We don't need to generate the data. We write the labeling functions. You give them tons of unlabeled data, and in tandem with the generative model, we train, for example, layout model. That's what we exactly have done. It. We show you the results, and it does perform very well than a default layout LM model because our data programming framework has given the model a lot of data to crunch from. So it instead of your way of transformers and then heuristics, what we do is we reverse this process, have a heuristic, have a principled approach of choosing the data points based on these heuristics, and then train a model. And this will be done in tandem. It's not like two silos. Snorkel does in silos, but our Sphere does together, and so it is effective for it to deploy in any type of formats.
Actually, Venkat made very important one more point. So the Snorkel framework from Stanford, what it does, it uses those programs or heuristics as use and throw. It says I'll use them to label data and then throw them away. So it's a cheap way of getting labeled data. We found that to be very flaky, honestly. In fact, even before we came up with our open source framework, we were trying to bank upon what they built. But their use and throw philosophy simply doesn't go well with us because these rules, if they coexist, the heuristics, if they coexist with the deep model, they can override at runtime as well, even at runtime. Whereas if you use these rules as use and throw to only create training data, then they have a role only to play during training. Does that make sense?
Not really, but that's fine because I also lost some of the initial context. Is there some place where I can place, is this open source in the sense that you must have released this, maybe you have written a paper or something, but is there also some code which I can play with?
Yes, we have code. We have
Okay,
code.
it's Decide team / Sphere. Fine. Okay. One last question I had is that since you have the data programming paradigm in place, is there some way in which we can quantify the how heterogeneous the different reports we are getting are? What I mean is, like Dr. Rao said, we are getting reports in very different formats. The variety of formats is very large, right? Like if you are getting from the same place, then you would expect them to follow exactly, well, maybe not one template, but at least a small enough finite set of templates, right? But that can change over time from the same place, or if you're getting them from multiple places, anyway, they will be different. Is there some sort of a way we could quantify this in the sense that we want to be able to say that we have a solution that works with a heterogeneity of up to so and so factor? Where by heterogeneity, I mean heterogeneity of the document layout. How would you measure that? Does that even make sense, first of all? Because if we say that we have a heterogeneity of 0, that means that every document is exactly identical to each other in formats, right? But if you have, let's say, heterogeneity of 1, that means that every single document is as different as it could be from somewhere else. So sort of variance within the layout. What do you think would be a good way to quantify that? And can we do that? That's basically something that will help us benchmark our solutions. Does it make sense?
Yes, sir. Can I answer this?
Yes, yeah, go ahead, Bintu.
Yeah, sir. What you call as like quantifying, maybe this can help to a certain extent. For example, how well the labeling function, since we are banking on the labeling functions that is going to fire on the data, unlabeled data, maybe this will be starting point to find out. Let's say we give you annotate for 10 types of data, and you give 10,000 unlabeled data that you don't know in what format you're going to get. We can do something kind of coverage, overlaps, conflicts, correct, incorrect is based on the ground truth, which we may not have. Empirical accuracy. This will help us to identify how this could be a starting point. It's a very important point that you brought up. This could be a starting point to assess. But since data programming has never been applied for OCR and medical domain, we can find out a way of how we can quantify this in a much robust way. But the starting point is here to find out how
Understood.
efficient the labeling functions are firing, which is not covered.
I
What are
think
the corner
coverage
cases?
overlaps
Again,
and conflicts alone should be fine, because the bottom 3, if I'm not wrong, they are more of a supervised learning kind of a thing. And this is something that we want upfront before anything is running. So maybe some sort of a weighted score of these 3 things, which you then normalize over the entire corpus or something like that.
Exactly.
Is that
And
what
then
you're
we have to
saying?
find the corner cases. Exactly. And then we can find out the corner cases and actually visually inspect and see why it is not doing that. That's how principally you write the labeling functions, basically.
Correct. Precisely. Because what we do usually to debug our solution is like, find that sample which has the highest loss. But then there isn't a single figure of loss for us. There is a loss could be contributed to by so many different things. So then, you can't sort by loss and look at, like, if it was a simple, vision problem, I could always say that, okay, this is the image that is causing the most trouble. But for us, that is not, it's not that simple in this entire pipeline. So that's what I meant. But fine. I mean, if this is something we can use, it's good enough.
Yeah, it's a very important question. I have noted it down. We'll surely take a look at from a research point of view. For example, if you can label the labeling functions, you can say that I'm writing a labeling functions based on visual features. I'm writing a labeling function based on key value positions. Then we can do a coverage based on these features. Say that some of the documents are not fired due to the visual features. Then we can inspect that, right? So that way, principally, we can approach these corner cases or the coverage, for this particular case study. Ganesha, making sense? Do you want to add on that?
Actually, I'm really enjoying the conversation because Mr. Jaydev is really getting the pulse of what. So you really hit the nail on the head. So the 3 plots on the top are unsupervised. Coverage, right? Overlaps and conflicts are unsupervised. The ones at the bottom, correct, incorrect, etc., they are supervised counterpart. And yes, you're right. So the first 3 at the top don't need labeled data, and we can think of improvising on them. Is there a way we can be more regular touch with each other, because it will really help? The questions you're bringing up are very important. We are able to relate to them. Maybe we can help further, refine this together. So this the way we can be in regular touch. That will be very helpful. Is one takeaway from today's discussion.
Yeah, sure. I'll drop my email address in the chat. Sure.
Okay, and if you don't mind, if we can have a Slack channel or a Hangout group or WhatsApp is also fine. Anyway, we can be in touch together. So, would you prefer Slack or a Hangouts or WhatsApp? Any of these?
Oh, I don't have a Slack server running anywhere, but yeah, it's fine. WhatsApp or
Sorry, Jaydev, to interrupt you.
Go on.
Professor Ganesh, actually, I have to leave for a CEO meeting urgently. So you may please continue. I need to drop off. Very sorry. Yeah.
Thanks. So,
Thanks, Doctor.
Dr. Rao, with your permission, we'll just create a WhatsApp group amongst us so that we can have more frequent exchanges. I hope that's fine.
Yeah. Okay. Thanks, Ganesh. Yeah.
Um,
Thank you, Neil sir, for attending. Yeah.
No, not at all.
Yeah. We'll also share this presentation. You can take a look at the demo video and keep it updated.
should we continue for some more time?
Yeah, I definitely have time. And since I joined a bit late, I would love to get.
Yeah.
Well, of course, I mean, you don't have to go present everything else, but I would love to see the presentation itself as well.
Sure.
Sorry, I just had one.
I can
Kind of as you continue with the actual the way the model runs, etc. More at a functional side, if supposing NHA was to use it, what could be a way to do that? Because from NHA, one thing is for sure, data can't move out.
So what we can provide are APIs. All of these at the API level, we can make them accessible to you. The code is open source. We can create API interfaces which you can invoke internally. And if you have your own overall pipeline, you can integrate that. And you can have that the API call within your pipeline. Right?
Okay, and we can deploy the code itself on our cloud.
Yes. You don't have to share data with us.
Okay. Yeah, please, Jaydev ji, you may continue. I'll log off now because it's too technical for me, by the way.
Sure, but
thank you, sir.
Venkat, Siddharth will just share a WhatsApp link. Request this, whoever is relevant, please do join it so that we can be in touch.
Yeah, sure.
NHA, sir, NHA link. NHA, what project?
No, just create a new one. And maybe Siddharth can create, and just share the link here.
Can you create and share? So it's great, Jaydev sir, that since you have worked with, we are having a technical discussion. I can be more vocal and free. For example, please. What you are seeing is based on a layout detection, layout LM model. The previous one was not working very well, and what we did is we integrated our Spear framework and coded based on this concept of DB scan, a very simple clustering algorithm. And we said that
DB scan as in the clustering, is it? Okay, got it.
Yes. Yeah, we simply used DB scan as a class labeling function, and then created the data and trained the layout element on top of that, and it was giving good results.
So tell me this, like, what are the features that you put into the DB scan? And like, I mean, the label would be just whatever your cluster label is there, but what are the features you put? Is that simply the output of the layout LM or what?
So what we did, OCR will give you the something happening here, but you know that layout LM needs 3 parameters: the word, the bounding box, and the class for training, right? Class is name, question, answer, header, footer.
Any
These are the
okay.
5. There are classes. So this is how the format is: a word, its bounding box, and its class. So like that, it should go for each row should have that. So what we did, we used.
Sorry, Venkata, just a second. Sushant, we are using the Hugging Face layout LM, right? Is that correct? Sorry, I think my colleague Sushant is there.
because layout LM, if you are using, you should be taking from Hugging Face, because the Microsoft one has some problem. The official,
Oh, I see.
right?
I didn't know there are multiple, but okay, fair enough. That's something that we also started with. Fair enough. So, okay, it takes three things: the bounding box, the class, and what else?
And Word.
And the word, as in the text word. Yeah, yeah. Okay.
Yeah. This is
Okay.
the input
And
for layout LM.
okay.
But what we did is, first we took the pre-trained model and tried to run it. It was not good. It was not giving good results. So we wrote a simple clustering algorithm. We know that. So like I said, I'll show you what we did. For this particular format, we ran one algorithm to separate these three areas, and for each areas we ran again, and we did a simple perturbation. We are in the process of publishing that, a simple perturbation to identify the row and column, and it gave a very good results on the tables. So it will easily identify the tables.
So these basically, what are the features that go into clustering? What do you use as features for the clustering? The same thing that you're using for AutoLM, is it? The same three things?
No, okay. The clustering is to find out. So OCR will give you the word and the bounding box, right? What we need to have is what class this belongs to.
Correct.
So for that, what we do is we run the clustering algorithm, the DB scan thrice, 3 times, to first identify these regions and identify the table, and then identify. For example, all this row, first column is name, second column is answer. Sorry, first column is question, second column is answer, third column is question, fourth column is answer. And the top one, which is not part of the table, is header. So these are the labeling functions we wrote.
No, I understood that, Venkata. My question is, like, let's say in clustering, you'll have to pass some as an input some matrix X, right? What are the columns of X?
Just one, no, the spacing.
This is a very specific case of clustering, right? And I think this is at the pixel level. You should. I think his point is, do you consider
I see.
pixels top of the image? It's just pixels, right?
Okay, interesting.
Yes.
Go on.
And then we wrote how many labeling functions we wrote, Siddharth? 2 or 3 at max, right?
I think it is. It's around 3. It's basically just the bounding boxes, bounding boxes, and the location of the bounding box.
It's actually templates. The labeling function templates.
Yes.
Because there will be instances of these labeling functions, right?
And then we can apply a joint learning with layout LM integrated. So we haven't tried. In fact, we have not tried with label set. We only had the unlabeled set and the labeling functions, and then a joint learning with layout LM on top of that, and then it ran. We just trained it. After that, we tested it on almost 200 data points, and it was coming good results. Exactly. You can see here that everything is identified properly. So I'll also run a demo.
Yeah, so the layout LM the deep model for layout LM that we used was not even fine-tuned. It was just off the shelf, right?
Just the default one, okay.
Yes. The default one, and then we fine-tuned it for our while.
We are very confident about it. The whole process involves only little label data, which is through the program. You don't even have to label data. And you can use an off-the-shelf model in conjunction.
So this is the result. I hope it's full screen.
It is.
You can see here we have this geometry. Okay, I'll just show some of the code. So this is unlabeled, just picture, PNG or JPEG image, and it's labeled here. I'll just run through the code since we are familiar with that. You can see here, this is the labeling function. We are taking the height and width of the geometry and putting it into the what is needed for the layout element.
Got it. Okay.
And then if you extract it, you can see here, the output will come here. Can you see the output? This is the key.
Oh, I
And this is
see.
the value.
Mm.
Specimen seven, visit type OP. This was giving like almost 95% accuracy. We were really happy and impressed because we did not label or we did not fine tune. All we did was write the labeling function.
Oh, this is good. This is exactly what I meant by, sometimes deep learning needs these tiny hacks here and there, which are like the hacks that we use are ridiculous in the sense that they are nowhere near as smart as whatever we would have done in the deep learning solution. But I don't know, sometimes we are a bit obsessed with those kind of things. So it never occurs to people to do this.
Yes, exactly. And this is where you are going on the right track. We just our approach is a little principled on the having the heuristics first and depending.
Correct.
Our belief is that any type of deep learning model is successful in doing things, but the problem is the availability of data.
Well, for that, I need 3 months of time to simply train the model and 50 people to sit and annotate it. If that I can get, then great. Then everything
exactly,
I'll do by deep
sir.
learning. No?
So that is where Sphere comes in the picture, where you don't need.
We are trying to leapfrog. That's exactly where we are leapfrogging. We are saying you don't want to go through that. It's not simply replicable. It's not scalable. It's not democratic. I think the Googles and the Facebook and the Amazon, they have a high hand in that. Whereas we want to democratize this process.
Yeah. Amazing. Good.
So
Sushant, are you there?
that,
Yeah, hello. Hi, Jared. Hi, everyone.
Hi. Do you have any questions?
No, let me go through this sphere documentation first of all. So I will get a better understanding.
Sure.
It's a quite impressive. Like, yeah, we have. Let's see.
So one of the things that we can start around hitting is, you said that you have some of the heuristics with you. What we can do is we can put those heuristics as labeling functions and see how it helps. Instead of having a layout element detection and heuristics, we'll put the heuristics into our Sphere framework and see how it covers the data.
No, that definitely worth a shot.
Immediately try.
Definitely worth a shot. I mean, I'll of course talk to Dr. Rao and see how we can get this started. My only worry at this stage is that, okay, I'll be very frank. Generally, whenever I've tried to, replicate a paper or tried to get code from a lab, I've almost always failed. That's because, typically the code is, usually written to sort of reproduce certain benchmarks that have been published somewhere. It's not always necessarily meant to be the kind of code that is ready to be put into production. But in any case, what I'll do is, in fact, I'd love to go through your repository and sort of even send pull requests wherever needed, so that we can get it to a working stage where we are using like Flask APIs around all of our machine learning code. So if you could put that around this and convert this into a service, that would be fantastic.
So in fact, for example, all you have to do is pip install Design Sphere, and you will have those framework ready and start writing the labeling functions on top of it.
Oh, I see. So you you have a package. Then great. Then I take my statement back.
Yeah.
If you have a package, it is clearly runnable.
In fact, we are now very
several other places. So Venkat, you can just flash Udan project. We have a big, machine translation, human in the loop machine translation project. Venkat is a flash that is being used extensively by AICT for translating technical content, technical books into Indian languages, like in really big scale, on a big scale. And it's the whole human in the loop is happening because of Sphere. So Sphere has been used in several other places. In medical image processing also, Venkat can also present that at some other point of time. So because it's being used, I think the more you use something, right, the more it gets robust, more it's ease of use. So,
See, sorry, what is this project?
this is about translation.
Udan.
I mean, yeah, Udan project. This is from a project I'm running. Since 7 years we have been on it, and this is a human in the loop. Your Sphere gets used here for injecting human constraints into the translation. Human constraints, for example, Venkat was showing the dictionary. If you go to that live translation, you can see these. You can see if you go down. You can see dictionaries, right? So these dictionaries are like human constraints. These are like programs. So you can get the
Hmm.
translation to understand by kind of having these constraints injected. At runtime, you're determining what constraints to inject, which dictionaries to inject, so that the vocabulary is influenced by the dictionary. So that's an example of use of data programming.
Okay, nice. By the way, speaking of this translates, what exactly does it translate, or it's capable of any text, is it?
Yeah, you can upload translate text. You can also upload PDF. So when Venkat can also show the PDF upload.
Acha, but primarily, let's say this is aimed at education.
Not necessarily. I mean, it's
Hmm.
being used for administrative as well, but not certainly not
No,
horizontal.
I was asking because I think the FOSSEE team has something very similar, right? Some textbook companion project or something is there.
I'm not aware. I'm honestly
Huh.
not aware.
I see that. If I'm not wrong, the FOSSEE team is at IIT Bombay itself.
Yes.
There's a possibility, yeah. Kannan Moduli. Again, no. So I think they were
Kannan,
using our.
yes, Dr. Kannan, yes. So they have this thing called textbook companion project, which it's kind of like an extended internship for everyone, where people can translate textbooks, and they get some stipend, and they can localize very specific technical topics into whatever their mother tongue may be. That is a corpus also you could use, but I mean, clearly that's just a thought. No,
So they were
it
actually
just
using
sounded very
the Udan.
similar to what they are doing.
So they were using the Udan system to help generate some of the translation. They are not
Mm-hmm.
the human in the loop machine learning platform. They are generating corpora. They have been in the past using Udan projects. So maybe that's why.
They would be like the ideal audience for something like this.
Yes. You're right.
All right. I think this was great. I would love to see the video demo as well as, the code. Code anyway I have. I'll definitely take a look at that. And I'll also speak with Dr. Rao about how we can pilot this within NHA and scope it out. Just give me a second. And could you... Anyway, yeah, thanks. I think I don't have anything else.
Okay. Sir, this is Bhupendra from CDEC Noida.
Hello, sir.
Hello, sir. Jadesh, sir, are you in office, sir? NH?
No, I'm not in office right now.
Okay.
I was planning to come by 1 o'clock. Would you need anything?
No, sir. Actually, I was in office. I thought you are in office. Then I should directly meet you. So that's why.
Oh,
No
I
issue,
see.
sir.
I'll definitely, I'll ping you when I'm in office.
Right. But sir, maybe by that time, I will reach Noida. Maybe, sir, some other day I will come, sir.
Yeah. I'll be there on Monday also. No problem.
Okay. Right.
Yes.
So just one question. Were you able to get access to the WhatsApp group? Were you able to join it? It was shared on the chat.
Let me see. Sorry, is that for me?
Yeah, if whoever is from your end can join, it'll just be. I think we need to have a communication gap because I visited Dr. Rao maybe 3 months back, 4 months back, and the talk is on and on. So I just thought we can.
Oh, no, I haven't received an invitation, or I don't see any new WhatsApp group yet. I have just dropped my email address in the chat.
Sir, can you
Sorry,
also
I've
show
dropped.
me the chat?
Okay. Yeah. Now I can. I see the link now.
If you can just you can add anyone else you think from your team.
Sure.
You got the link, right? Okay.
I did. I'm in the group now.
Okay, great. So Venkat, let's just share all of that there. And this recording also I share the link in case you want to refer that to.
Yes.
Okay. Is that fine? Anything else we should discuss?
Nothing from my end. And I think, Bhupendraji, you have any questions or should we conclude then?
No, sir, no, it's okay, sir.
Anyone else?
Sushant?
No, Jadhav, thank you.
All right. Thanks a lot, folks.
Thank you. Thank you, everybody.
Bye.
Thank you.
Yeah, thanks everyone. Thanks.